Hello there. In this video we are going to look at Spanning Tree Protocol, Dynamic Trunking Protocol and VLANs. We're going to use Packet Tracer, Cisco's Packet Tracer, and obviously what you can see in front of you, you'll see that the scenario that we're going to use and that I'm going to go through. So effectively painted this type of if you try and imagine that, for example, you're the IT network administrator for company X, and within this company there are two departments. So you've got IT department in blue, these workstations in blue, and you have finance department in orange. Geographically within the office it doesn't make any difference, but for the purpose of this video, they're color coded just to show you, just to separate them. So what we need to do, we need to isolate the IT department with the finance department, essentially, and we're going to use VLANs to do it. Once we have isolated the IT department equipment with the finance department equipment, we will test connectivity between the PCs within the same department, and we will prove that you cannot access PCs from the other department. The router on this diagram is to show you how you can access the two different departments if you so wish, but by using inter-VLAN routing, or in other words, router on a stick. Okay, and it's the router that will perform this function. So in this video we're going to use VLAN 10 is going to be the IT department, and VLAN 20 will be for finance. As you can also see on the diagram, we're going to be creating a form of redundancy within the network by introducing dual connections on all switches. Alright, and yep, so without further ado, we will just run through the objectives. So that's what we see now. Configure access or trunk links, create VLANs, assign VLAN memberships, configure into VLAN routing, which will be at the end. We'll configure the VTP server, make VTP clients on the switches. We will show the Spanning Tree Protocol in action, and we'll configure the dynamic trunking port as well. This is the table of information that we're going to use to configure Packet Tracer and all the relevant devices. So what can I suggest is, if you're going to follow this and do it yourself, pause the video, capture a screenshot perhaps, and then obviously carry on and watch me. You'll be able to use this information and obviously apply it to your own diagram. Incidentally, I'm using Packet Tracer 6.01, the latest version available, which is freely available. Okay, so this is Packet Tracer. We're going to jump straight in. Just before we start, I've put a little note at the top right hand corner of the screen, just to remind you that IT department is VLAN 10. Finance department is VLAN 20. I've also included the IP addresses for the two different areas, so PC 0 up to 5. So effectively there's 3 PCs in VLAN 10 and 3 PCs in VLAN 20. Okay, so let's go. Let's start putting the client machines in. So we'll put one here, here, here. Okay. Ooh. Sorry. Okay, so these are 6 client machines, based nowhere specific, in company X. Right. So what we need to do is rename them so it makes it easier for reference later. Rename them and also configure IP addresses. So using the table above, 2. So that's PC 0 done. We'll do PC 1 now. using standard class C masks. The last one, PC5. And there we have it, the client PC's IP address is set up, and we just need to now get on with the remainder of the topology. So what we want is a switch, so we'll use a 2960. And we'll put one here and another one here and another one at the top here. Okay, so now let's just rename these. So switch, excuse me, switch 1, switch 2, didn't take that one, switch 2. Okay. What we want to do now is grab some cables, some Cat5 cables, straight throughs, and plug each device into the switch. So using the diagram again, so PC0 will connect to switch 1 on fast Ethernet 01, and then PC1 fast, pardon me, straight through cable to fast Ethernet 02, and PC2 grab another cable, PC2 on switch 2 we'll go to fast Ethernet 01, and again PC3, excuse me, and we'll repeat the same for the last two devices. Okay, so that's the three switches, 6 devices connected. As you can see already, the interfaces are coming up. Switch 1 is already up, switch 2 and 3 are coming together. The final device we have to put in, install here is the router. So we'll pick a 2811, put it all the way up here. And so now all devices are on the map. We just need to connect them all using the crossover cables. So again, using the info, we'll connect gigabit 11 with the router. Okay, so that connection's coming up, and then we want to connect again crossover from switch 1 gigabit 12 with switch 2 gigabit 12. Let's match them up. Another crossover cable, port 24 F024 with switch 2, 24 as well. Let's match them up for completeness. So that's creating the dual links between the two switches. Now we'll go ahead and do switch 2 to switch 3. So on switch 2, so gig 11 to switch 3. Excuse me. final connection F023 24. Okay, so that's all the connections there present. As you see, they're amber at the moment because they're establishing. They're doing the algorithm, going through the STP spanning tree just to see which is the live ports, which is the blocking ports. So what we can effectively do now is just to test connectivity. So in theory, PC0, which is in the IT VLAN, should be able to communicate with PC2, which is on 10.0.0.3, and PC4, which is on 10.0.0.4. Okay, we'll test that now. We'll just bring up an emulator command prompt, and we'll do ping 10.0.0.3. There you go. And we'll do 4 as well. Perfect. Just for completeness, if we have a look at this, the finance PC or laptop is on 20.0.0.2. Just show you, ping 20.0.0.2, nothing, completely isolated. Okay, so next we're going to create the VTP or the VLAN trunking protocol, and we'll first have to create the VTP server, which will be used to propagate VLAN information to the other switches. We'll use switch 1 to do this, so we'll go into the CLI now and start off. Let's go in here, just expand it a little bit. Okay, so let's go into enable mode. Right, so we do VTP mode, conft VTP mode server. Okay, so it's already a server. VTP domain, create a domain. Without this, it will not work. So let's just call the domain, for example, for this video, company X. And for security, we're going to create a password that the VTP clients will use to communicate. If this password is wrong, they will not share information to each other, or the server won't communicate to the client, the VTP client. So let's just create a password called secret. Right, and that is it. Bam, done. So the VTP server is set. I can come out of here. Right, and now we need to move on to switches 2 and 3 and effectively create the VTP clients. Right, so we'll go into switch 2, CLI. Just make this a little bit bigger. EN, so VTP mode client. Sorry, I've done it again. VTP mode client. Okay. And then VTP, we need to join it to the domain, or the VTP domain, company X. Okay, and also specify a password, which is secret. And that is done too. That's complete. So let's quickly move on to switch 3. And we'll do exactly the same. I'm going to whiz through this because it's self-explanatory. I'm just repeating myself. VT mode client. VTP domain, company X, VTP password, secret. Okay, so VTP is now configured. So now all the switch ports remain by default in access mode. Okay, so access mode can't transfer the trunking frame and therefore will not pass VLAN information. So what we need to do is change the mode on each of the trunk links to trunk, and each of these connections, the ones we need to change are the connections that run between the switches. So these two here to here, and then here to here, and we're going to do that now. So first of all, we go to switch 1, back into the CLI, enconf-t. So we want to go to the interface, into this interface specific command, obviously. Internet fast 24, 024, which connects to switch 2. That's one of the links. And we literally give it a switch port mode trunk. Oops, sorry. Okay, that's done. And then we will configure the other interface. No, sorry, it's gigabit 1/1. Up, trunk again. Interface gigabit 1/2. Switch mode trunk. Okay, switch done. 1 done. Let's now configure switch 2. That's the first interface. 2. That's the second. And then we need to do 23. These are the connections to switch 3 now. 24. Okay, so that's switch 2 completed. Let's go to switch 3. Okay, that's the trunk ports set up. Now we need to move on and create the 2 VLANs, the IT department and the finance department, on the VTP, which is switch 1. Okay, so let's go into switch 1, CLI mode. Okay, so basically what we're doing now, the switch 2 and the switch 3 act as VTP clients, and they're configured so that they will pull information from the VTP server, which is switch 1. So that's why we only have to apply it to the VLAN configuration to switch 1, and it will propagate to the other 2 switches. Right, so conf-t, we'll do VLAN 10. Okay, so that labels a VLAN straight away. No other configuration needed. So we'll do 10, and now we've done 10. We'll do VLAN 20 for finance, and that's the VLANs labelled. And now we just need to assign the VLAN memberships on switch 1. Right, so conf-t int fast Ethernet 0/1, which connects PC 0. So switch port, we want to make this an access port, VLAN 10. Oh, VLAN 10. Okay, so that's effectively putting interface fast Ethernet 0/1, tagging it as VLAN 10. Okay, and exit. We'll do interface fast Ethernet 0/2, switch port access mode, VLAN 20. That's done. Right, memory. Okay, come out of here, switch 2, do a similar type of exercise. Switch 3. 3. My mistake. VLAN 20. So that's the ports on the switches, the ports that are directly connected to the PCs configured. We can again just make sure everything is working by pinging PC1 with PC3. So ping 10.0.0.3. Yep, so that's working. And we'll do 4 as well, and that's pinging PC0, pinging PC5. From here it's pinging PC5 with success. And really what that's proving now is that VTP, the server, has propagated the VLAN information to the other two switches. What we can do, just to show this, just to give you an example, let's look at switch 2. Let's expand this a bit. If we just do a show VLAN, I'll explain what's going on here. You see the 2, it's obtained the details from the VTP server, which is switch 1, and as we did, we confirmed, well, we configured port FA01 on this switch to be VLAN 10 and FA02 to be VLAN 20, the finance. All of these are unconfigured, so they're on default VLAN 1. Yep, and there we are. So what we can do now, just quickly to give you an example of Spanning Tree in working in all its glory, so to speak. As you can see, gigabit 1 is the forwarding, and this is active as well. As you can see, it's orange, but it's in a blocking state. So what we can do is we can effectively force STP to change and elect a new root port by manually shutting down gigabit 1.1, and you'll see that going red, and this will renegotiate and become an active port, and this one up here on switch 2 will subsequently block out as well. You'll see it happen. So let's do gigabit 1 int gigabit 1.1. If we shut down, okay, so just watch those green lights when I hit the shutdown button. Okay, down. So that's obviously gone down, and you'll see this one renegotiate. That one's gone green straight, or that one stayed green. Let's just give it a few seconds because it does take a while. Just prepared to bring this back up. Obviously, the reason why one port will block, why one port will be the designated root bridge or the forwarding port is beyond the scope of this diagram or this video, but I will cover that in the next one, or one of the videos to follow. There you go. As you can see, it's come back up. If we put the interface back up by doing no shut, it's going to do the exact reverse. See, that's gone into a blocking state. This is renegotiating, and gig 1.1 will become the forwarding port. Right, so we'll leave that there. Close this for now. So what we've done up to this point, we've configured 2 VLANs, separated finance and IT. The last thing we need to do is to configure the router on a stick that will effectively allow PC0 from IT to communicate with PC1 in finance. Okay, so the process is relatively simple once you know how, and it requires creating sub-interfaces on the interface that's connected with the switch 1. So we're going to go in there straight away now, and go in here, say no to the initial dialog. Okay, go to enable mode. Okay, so it's fast Ethernet 00 T fast 00. We do no IP address because we need to create sub interfaces. So just good practice just to make sure we clear down the interfaces. Let's bring it up as well. No shut. As you can see now, it's gone green. So now we need to create the sub interfaces for the two VLANs. So int fast Ethernet 0.10, meaning VLAN 10. Okay, encapsulation dot 1Q10. That's effectively telling that sub interface that it's VLAN 10, and we will give it an IP address on the VLAN 10 network. So IP address 10.0.0.1 255.255.255.0. Exit, and we'll do the same for the VLAN 20, again on the same interface, but it's a sub interface. VLAN 20, go up, save a bit of time, and we're electing that to be VLAN 20, and we'll give that an IP address from the finance network. Okay, and that's that configured. So let's see now. Let's just make sure firstly that the PC0 can now communicate with router 1. So first, we haven't got a default gateway set, so we now have to specify what the default gateway would be for PC0. In the real world, router 1 would be connected to a WAN link here, so the gateway would be router 1. So we're going to IP configuration for the PC on the IT LAN. We will put 10.0.0.1 and close that, and finance will do 20.0.0.1, which is a sub interface on router 1. And just quickly 10.0.0.1 20.0.0.1 10.0.0.1 20.0.0.1. So that's that done. If everything's working correctly, we should be able to communicate across the VLANs into VLAN routing via the router. So first of all let's make sure we can ping the gateway from PC0, and we can. And now we're going to test trying to ping the finance PC1 down here. So we'll ping 20.0.0.2. And there we go. So that's the router doing its job. It's passing traffic between the VLANs using the sub interfaces. Just make sure we can ping this PC down here. Nothing wrong there. And that's into VLAN routing using, or one for the better term, router on a stick. That completes this video. Thank you for watching, and what we'll do, I'm going to be creating another one using Cisco ASA, slightly more technical level, but just check my YouTube channel. There's plenty more videos on networking and different technologies. There will also be GNS3 videos to follow shortly soon. Thanks for watching.